Now acceleration, we are going to discuss the acceleration. Okay, acceleration, we have already gone through the velocity, speed, huh? We have already gone through the velocity, speed and speed. Velocity is a vector quantity, whereas the speed is a scalar quantity. And now see, whenever we are riding on some vehicle and somebody says us, who is sitting behind us, that just accelerate it, speed बढ़ाओ, velocity बढ़ाओ, हाँ. तो ये जो एक्सीलरेट वर्ड है, मीन्स एक्सीलरेट वर्ड में क्या हो, इसको हम समझे. एक्सीलरेटर विच इज वेल नोन विद अस, एवरीबॉडी इज नोइंग एक्सीलरेटर. इफ यू आर हैविंग सम व्हीकल विद यू, it may be a two wheeler or it may be a four wheeler, in that accelerator is there. Accelerator means it is changing the velocity. Now there is a change, it means this word acceleration is well, accelerator is well known to us. Similarly, it is related, means definitely it is related with the acceleration. Okay, now acceleration means change in velocity, change in velocity with respect to time, with respect to time. Or simply we can say it is the change, it is the change in velocity with respect to time. Okay, so change in velocity divided by the time taken it, or we can simply say time rate of change of velocity, time rate of change of velocity. This is acceleration. It is acceleration and it is represented by generally A. A. If you are writing it like this, it is a vector quantity. Acceleration is a vector quantity. Now we know the velocity, the SI unit of velocity, that is meter per second. And time taken is also having the unit which is equals to this. So ultimately what we are having, meter per second square. So SI unit of this is meter per second square. Similarly, if we talk about the CGS unit, it is going to be centimeter per second square. Centimeter per second square. Okay. Centimeter per second square. This is the CGS unit. Now dimensional formula or dimensions. So here we are having meter, which is represented by length. In previous lecture, we will go with a lecture of dimensional analysis separately. Just understand length, which will be given by L. Second, which is given by time. So it is going to be L. I am writing it here, m l t raised to the power minus 2 0. M raised to the power 0 means 1, L to the power 1 and t to the power minus 2 is the dimensional formula for this acceleration. Okay, now we have got the definition that change in velocity with respect to time, or time rate of change of velocity. Velocity is a vector quantity and dimensions which we have got this. Now if we go through the types of acceleration, so again we are having the same types which we have got in velocity as well as in speed. Now if we go through this, so first is uniform acceleration. Second is non-uniform acceleration. Now see here, non-uniform acceleration, average acceleration, and fourth is instantaneous acceleration. We'll go one by one to define it. Okay, now here we will go with the uniform acceleration. I'm writing it in short, uniform acceleration. Now uniform acceleration, it is the change in velocity, or we can say equal change in velocity and equal interval of time then it is said to be uniform acceleration. Uniformity is the equal change in velocity in equal interval of time. Then it is going to be uniform acceleration. Now here we are going with the non-uniform acceleration. Second is non-uniform acceleration. Non-uniform, uniformity is not there. Here it is uniformity. Now it is, we can say it is the equal change in velocity in unequal interval of time then it is said to be non-uniform acceleration. Now what we have got? We have got these two types. Third is average acceleration. I am going to define it here. Average acceleration. Now in average acceleration, it is the total change in velocity and in a total time taken and time taken, then it is said to be average acceleration. Okay, so if we go with the average acceleration here, average acceleration, suppose I am having an example. At the time of t1 the velocity is v1 and at the time of t2 the velocity total change in time is velocity v2. So change in velocity will be given by v2 minus v1. This is the change in velocity. And time taken, this will be given by t2 minus t1. So we can have v2 minus v1 divided by t2 minus t1. This will give the acceleration. Okay. Now here we can say change in velocity upon change in time, del v upon del t, or simply dv by dt. Where change in velocity with respect to time, this will give the average acceleration and the way which we can take it this. Okay. Now here, now what is instantaneous acceleration? If we go with the instantaneous acceleration, the simple word instant, at a particular instant of time, instantaneous acceleration. It is defined as the change in velocity at a particular instant of time. Particular instant of time. At a particular instant of time, then it is said to be instantaneous acceleration. Okay. Now see here, in instantaneous acceleration, we can assume a very small change in velocity, that is del v, and there is a change in this del t time. So this will give the acceleration, and limit del t tends to 0. Limit del t tends to 0. This will give us the instantaneous acceleration, and we can say dv, if it approaches to this, dv by dt. So at a particular instant of time, the acceleration which we are getting because of the change in velocity at that particular instant of time, then it is going to be instantaneous acceleration. Now here we have got these 4 types, but what happens? Sometimes velocity is increasing. You are increasing the velocity to reach at the earliest, or sometimes you are decreasing the velocity to stop your vehicle, or whatever maybe it is. So यहाँ पे we can have, suppose we are having v1 and the velocity, this is the initial velocity, we can take it as initial velocity, and this is final velocity. Now we have got this change in velocity, v2 minus v1. Time here we can say time at time t1. Here we can say time t2. Okay. Now here t2 minus t1, there is always a change in time. Time may not be negative here. Now here, if v2 is greater than v1, means the velocity is increasing. Velocity is increasing. Then we can say it is a positive acceleration. We can say it is a positive acceleration because the value which we are going to have, the difference which we are going to have, v2 is greater than v1, so definitely it is going to be positive. So that acceleration will become a positive acceleration. वो क्या बन के आ जाएगा? Positive acceleration. Now just simply we call it as an acceleration only. Means there are again on the basis of change in velocity, on the basis of change in velocity, we can differentiate it by either positive acceleration and second is negative acceleration. Now we have gone through the positive acceleration, v2 minus v1 upon t2 minus t1. v2 is increasing as compared to v1, means there is an increment in the velocity. जब इंक्रीमेंट होगा वेलोसिटी में तो एक्सेलरेशन जो होगा पॉजिटिव होगा, और पॉजिटिव एक्सेलरेशन that we can simply call it as an acceleration only. Now if see here v2 minus v1, again we are taking t2 minus t1, acceleration is there. Now v2 is less than v1, velocity decreasing. So change in velocity may be negative. v2 minus v1 will become negative. Negative change in velocity. And if there is a negative change in velocity, the result will be A will be negative acceleration. There will be negative acceleration. And we call it as a retardation. We call it as a retardation. So here Positive acceleration, that is, we call it as an only acceleration. Here negative acceleration, we call it as a retardation. So when there is a change in velocity which is negative, then it is going to be retardation. And when there is a change in velocity is positive, then it is going to be positive acceleration. So this way we can have an acceleration. We have discussed in the previous lecture about velocity, speed. Now we have got this acceleration. Now in next lecture we will go with the equation of motion. Okay.